Question 11, Part F. Use the substitution u equals e to the power of 3x to evaluate the integral of e to the power of 3x over e to the power of 6x plus 1 dx from x equals 0 to x equals 1 over 3. Starting with the substitution u equals e to the power of 3x, differentiate u with respect to x. And we get du dx is equal to 3 times e to the power of 3x. Now, looking ahead, the original integral involves an e to the power of 3x dx. And we can see that here. In fact, if we rearrange the equation, we could make e to the power of 3x dx the subject. And we do that by moving the differential dx over to the other side by multiplication and moving the 3 on the right-hand side over to the left-hand side by division. So we get 1 over 3 du equals e to the power of 3x dx. Now later on, I'm going to replace or substitute e to the power of 3x dx with 1 over 3 du when we express the integrand in terms of u. Now I'm going to change the limits of integration from being in terms of x to being in terms of u using the substitution. So when x equals 0, so that's our original lower limit, u is equal to e to the power of 3 times 0, so that's e to the power of 0, which of course equals 1. So the new lower limit is u equals 1. And when x is equal to 1 over 3, which is our original upper limit, u is equal to e to the power of 3 times 1 over 3, so that's e to the power of 1. So our new upper limit is u equals e. So the original integral can be written in terms of u, so that equals 1 over 3 times the integral of 1 over u squared plus 1 du from u equals 1 to u equals e. So performing the integration, we get 1 over 3 multiplied by arctan or inverse tan of u from u equals 1 to u equals e. Applying the limits of integration, we get 1 over 3 outside of arctan of e minus arctan of 1, and arctan of 1 is pi over 4. And that gives us 1 over 3 outside of arctan of e minus pi over 4 in brackets.